expertise on optimization techniques with PSO genetic algorithm. So on my request, he has he will deliver these lectures on PSO and genetic algorithm. So I, on behalf of NITR, I welcome you, sir.
Thank you. Thank you.
And you start the PSO. So any questions, any query, you directly ask Dr. Harish Garg from Thapar University. Please go ahead. So participants, be ready for this session. You continue.
Okay, so good morning, everybody. So myself, as my friend Dr. Kailash introduced me. So thanks for giving me an opportunity to deliver a lecture on my specialization, that is a particle swarm optimization and the genetic algorithms. Okay, so since this is a part of the optimization techniques, so very basic, what is the optimization? Because whenever we are talking about any swarm optimization technique or any evolutionary algorithms, the basic idea behind these evolutionary algorithms is the optimization. And the question is, what is the meaning of the optimization? Okay, and then how we can tackle our real life problems by using the optimization techniques. So before start, what's the firstly things come in our mind whenever we are talking about the optimization? What's the first thing? That is, if any objective function, like say this is there, any real function fx, okay, and either it can be minimized or it can be maximized. For example, if somebody want to purchase XYZ units, okay, or XYZ product, then our target is to, if our target is to profit, okay, then our goal is to maximize the profit. Or on the other hand, if our target is on the cost, then it's minimizing the cost. So the function f, it may be the linear, it may be the non-linear. Okay, like say a plus bx, okay, or it may be like x square. Okay, subject to the some constraints be. Okay, like say budget. अगर हमारा target है, if our target is to minimize the cost, okay, but our budget is 1 lakh only. Okay, so that gx is less than b. G is my cost function, is less than equal to 1000 b. Okay, and our target is to maximize the profit. So fx is my profit. So say a sugar industry is there, and there are a lot of components inside it, and the target of this industry is to maximize the profit subject to some constraints, and constraints are our budget. My budget is 100 crores. So within that budget, I want to maximize the profit. Okay, now the target is should I able to do or not be? Okay, but sometimes it may that our target is to maximize the profit, but somebody say no, it is not possible to maximize the profit within that budget, within the 1 crore, within the 100 crores. So somebody say I don't bother about the budget. So somebody say then that constraint g of x is less than equal to b, that is equation 1.2 is omitted. But if somebody say you have to maximize the budget subject to that constraints, within that constraint, that is a 1 crore or 100 crores, okay, within that budget you have to maximize the profit, whatever the constraints are there, whatever your profit, it may rupees 5, it may rupees 10, it may rupees 15. Okay, and this 1.3 is my lower and upper bounds. Say any sugar industry have to manufacturing 5 units of XYZ system. Yeah? Okay, so that system, that's the 5 units. So maximum 5. So XU, this is XU is my 5. Okay, and this XL is minimum number of the units are 0. So the bounds are lies between 0 to 5 and so on. So that problem is to maximize, is to solve this optimization problem 1.1 subject to the 1.2 and 1.3. Okay, so any solution, okay, our target is to find this number of the x1, x2, x3 and xn. This is our target. So any vector which satisfy equation 1.2 only, which satisfy only 1.2, that is called as the solution, only solution. Okay. Now, if any solution means if any x which satisfy equation 1.2 as well as equation 1.3 both, okay, then that solution is called as the feasible solution. Okay, so it may take a more than one feasible solution. So out of that feasible solution, which one is optimizing 1.1? Okay, so that is called as the optimizing function, optimizing solution. Okay, so what's the first things come in your mind whenever I say how to solve equation 1.1 subject to the 1.2 and 1.3? As we study in our lower classes, the first derivative is 0, second derivative is greater than 0 or less than 0, depending upon their maximization and minimization. All of you know that? Okay, but what are the problems? Is it able to do the derivative easily? If I say x square plus 1 is a function, then you can easily solve its derivative, 2x plus 1. That's no, 2x. Okay, but if I say my function is sine inverse of tangential logarithm of x square and 2x plus 1 and so on, then it's very difficult to find the first order derivative. It may that the first order derivative is easy to calculate, but the higher order derivative, second derivative, third derivative is not an easy to task. Okay, so what are the practical optimization problem? What are the characteristics of this is called as the constraint optimization, because 1.2 is there. If instead of the 1.2, if I just omit the 1.2, then that type of optimization problem is called as unconstrained optimization problem. Means there is no boundation on that. Okay, if 1.2 is included, then that problem is called as constrained optimization problem. And if any of the function f of x or gx, if either fx or gx is non-linear, okay, then the problem is called as non-linear optimization problem. It may that f of x is non-linear or g of x is linear, okay, then the problem is again non-linear. On the other hand, if fx is linear and g of x is non-linear, then again it is called as the non-linear. Now, so the first one is objective and the constraint functions can be non-differentiable. Okay. Now, second thing is the constraints are non-linear. Non-linear means they have high complexity. If I say a function is non-linear, when I say a function said to be non-linear, if the rate of the change is not constant. If I say x square is a non-linear because its derivative is 2x. For the different value of the x, its values are different. So that's why we call it as a non-linear. But if I say a linear function, that is a plus bx, what's the rate of the change? What's the derivative is b, and that is a fixed number. This is independent of the x. That's why we call it as a linear function. Okay, or somebody says that a degree 1 is called as a linear, but sometimes it's not true. If I say mode of x, okay, so mode of x again x की degree 1 है, okay, but it is a non-linear because the rate of the change is either 1 or -1. Okay, so for the different value of the x, they have the different value slopes. So that's why mode of x is a non-linear. Okay, so again the constraints are the non-linear. That's meaning that is any constraint whose rate of the change is always be is a variable number with respect to your decision variables. Second is the discrete and the discontinuous search space. That is my equation 1.3. That is the lower and the upper bound. If I say I want to manufacturing the products, okay, like say this marker is there, so we can't manufacture 1.5 products, 1.5 marker. Okay, so that is a discrete number. If I am just talking about 1, 2, 3, 4, 5, that is a discrete. So if somebody say 1.5, 1.2, okay, 4/3 and then so on, like the number of the marks obtained by the students. Okay, so it may take 21.5, 33.5. Okay, so that is a continuous. Okay, so discrete and the continuous search space, one is the characteristics is there. Second, the mixed variable. Okay, it may have some variables are the discrete, some have the real numbers. Real number means from -infinity to +infinity. Some have the integers only. Okay, some have the booleans only. That is either 0 or 1. And the large number of the constraints and the variables. G of x is less than equal to b. That is equation by 1.2. Okay, sometimes it may have constraints are more than 10. So it's not an easy to handle these 10 equations. Okay, it may take, if the constraints are only 1, then I can easily solve that. Okay, and the last one is objective function can be multimodal. Have you heard about the word multimodal? No, that is a multi-objective, but here is a multimodal. The one term in the statistics is mean, median, mode. Yes. Okay, so in that case, what is the meaning of the mode? Mode is the highest number of the frequency. Highest number of the frequency. So multimodal means if they have more than one, that is a more than one mode are there. If I say number are my 1, 2, 2, 3, 3, 4. So here 2 and 3 are occurring 2 times. My numbers are 1, 2, 2, 3, 3, 4. So the highest frequency are 2 for the number 2 and 3. Okay. So objective functions can be multimodal. Like say a simple example, if I say my objective function is x square, okay, and my domain is -1, 2, +1. Okay. Okay. Then at point x is -1, the objective function is 1. Okay. And at the point +1, again objective function is 1. So this is called as the multimodal. So that is multimodal function have more than one optimum. Okay, so more than one optimum means if you are talking about the minimization, then it's the minimum objective function. If it is maximization problem, then it's a maximization. Like say if I say maximization of the x square subject to the -5 to +5. So at the -5 objective function is 25, +5 is again 25. So the optimal answer is -5 and +5. So that is a multimodal function may have more than one optimum, but can either have a single or more than one global. Have you heard about the word local and the global solution? Okay, so local is one in the neighborhood, global is complete one. Okay, highest frequency in the whole set. So and the last one is the computational expensive objective functions and the constraints. If my objective function is only 1, but the constraints are 45, okay, then it may take a lot of the computational steps to satisfy all those constraints, because without satisfying all those constraints, you can't find the objective functions. You can't solve the optimal. You can't find the optimal value. Okay. So similarly, so that's why I say the computational expensive of the objective functions as well as the constraints. Okay. So these are the some characteristics of the objective function. That is our any. How would we solve that, sir? How would we solve that? That's the main task is there. Okay. Now, what are the basic problems that we have faced during these 6 and 7 points are there? If I say my objectives and constraints are non-differentiable, then what will happen? Is there any limitation behind that or not? So that is the traditional optimization techniques problems. Like say, all of you know that how to solve the optimization problem. First derivative to be 0, then second and third derivatives to be less than or greater than 0, depending upon their problem to problem. The first one is different type of the methods are applicable to the different types of the problem. For example, if I say my objective function is non-linear, x square, okay, then you can easily find the derivative and to be put them to be 0, second derivative less than and greater than 0. Okay, but if I say my objective function is linear and the constraints are also linear, then what type of the methods we have used for finding the optimal solution? Linear programming, simplex method, transportation problem, and then so on. Okay, listen. Duality is there. So all the LPP models are there. So what is means? Different methods for the different type of the problem. If I have a linear programming problem, then the simplex method, duality, transportation, assignment is there. If my no linear programming, then the first derivative is 0, second derivative is less than greater than 0. If I have no linear problem instead of the quadratic, higher methods are there. Then there are the different types of the methods. So there is no single method for solving the one type of the problems for in the optimization technique. So this is a basic challenge B, because somebody say I have good knowledge on the optimization technique for the linear programming problem. So if somebody say optimize the x square, so that's a non-linear. You can't solve the simplex method for the objective function x square. So the person who have knowledge of the simplex method, they are not able to solve the function of the x square and x cube and then so on. So that's why I'm just saying that different methods for the different type of the problems. Okay, so that is the basic problems that have used in our classical approaches. Means if somebody want to solve the nonlinear optimization problem, they have to know how to solve the nonlinear programming problem. Then second is the constraint handling. Constraint handling means if we have the 45 constraints, then there is a big task how to handle these 45 equations, 45 constraints. And definitely one usual simple method is Pildanti method. Okay, you have to impose some values like say 5,000 to the first constraint, okay, 10,000 for the second constraints, and then so on. If you know about the big M methods, okay, then you have to take M, okay, and M is a very large value, okay, but what's the that value be? What is the meaning of the large value? Somebody say 10 crore is a large number B, but somebody say 10 crore is not a large number B, 100 billion is a large number B.
That value which is highest from all the variables.
All the variable in the constraints.
In the constraints B. But if I say my 45 number is the highest number B, okay, so it means M you can take a 45. But if somebody say I am not interested in the 45, I am taking a 95, that's also easily solvable. Okay, so that's the main constraint handling, that is using the Pildanti method in the sensitivity to the Pildanti parameter. If somebody say M is 45, okay, or M is 1000, so this is not an easy way to calculate what is your M. Okay, if some particular problem is solved with the help of the M is 45, then the same problem can be solved for M is equal to 65, okay, and so on. So it is a very difficult to choose the Pildanti parameters. That is the meaning of this one. Okay, if there are more than 45 or 50 constraints, then it's not an easy task to find all those M's. Then often get stuck in the local optimum. If somebody local optimum means that is called as the local solution. If I say x square is my function and x is equal to 0 is the minimum point, that is no issue. Okay, but if my objective function and the constraints are no linear and highly complexity is there, so it may have, okay, that my solution is truncate at a single point. That is called as the premature convergence. Premature means if we are finding that solution that is stuck off, एक बंद कमरे के अंदर हमने कह दिया कि यहाँ पे fix हो गया solution, so then all the times whenever we moving on the iterative point of view, then the solution get at a single point. So that is called as the stucking at a single point. That is, we get the local optimum, not getting the global optimum. But our target is to find the global optimum, because local optimal is not the optimal solution. Local optimal is the optimal solution, but within the small interval. But that convex set. Every local is a yeah, that's true. Our objective, if our objective function is convex, okay, then every local solution is a global solution. Or you can say every U-shape function is a convex function. Simple example is x square. What is the shape of the x square? Is a U shape. Okay, so every U-shape function is a convex function. So if you get a local solution, it means local means globe. Okay, and then usually there is a need to know how to calculate the first and the second derivative. But if somebody is non-mathematics student B, okay, somebody is don't know how to calculate the first derivative and second derivative B, then I think there is a problem for calculating the derivatives as well as the corresponding optimization function. How to find the derivatives, because the traditional methods are first derivative to be 0, second derivative should be a less than or greater than 0 B. But if the candidates is unable to find the first and the second derivative, what it means that they are unable to solve the optimization problem. Okay. Then most again the same. This is a basic problem. These are 4 problems. Apart from that, if somebody know how to calculate the first and the second derivative, that's true. But the objective function is highly complex in nature. A lot of factors, a lot of the terms are involving in the objective function. Then it's not an easy to calculate the first derivative as well as the second derivative. Okay, I say the first derivative you can easily calculate that. Then how to get the local solution? You have to take first derivative to be a 0. If I say first derivative to be 0, then you have to find the value of the x which satisfies that equation B. So if I say x plus sine x is equal to 0. After the first derivative, you get x plus sine xb. Okay, like say my objective function is x square by 2 minus cos x. Okay, my objective function is x square by 2 minus cos x, and you want to optimize this function. So you take the first derivative, that is x plus sine x is equal to 0. Then you have to find the value of the x which satisfies this one. Okay, so if somebody know how to calculate, then it's easy. But because you can't calculate easily x is equal to minus of sine x, then there is no value apart from the x is equal to 0. Okay, you have to use the iterative methods, and numerical techniques are there. Okay, bisection method, regular Folsian, and so on. Okay, but if somebody is, that's the basic problem, because x is plus sine x is equal to 0. So how to find the value of the x? And for the second derivative, that is 1 plus cos x. Okay, so for what value of the x plus sine x is 0. So that is the basic task. Okay, so in order to handle all these problems, like say different method for the different type of the problem. Okay, so we need one methods for solving all those optimization problem. Either the constraints are 45, either the constraints are linear, either the constraints are non-linear. Okay, either objective function is linear or non-linear. So we have to find a methods. We have to create a new methods which solving all this type of the problem in a single platform. Second is easier to calculate, easy to handle the constraints. That's again our target. Okay, and our target is to get the global solution instead of the local solution. And our target mostly to remove this first and the second order derivatives. We have to create a such type of the methods, okay, in which the first, second, third, fourth order, higher order derivative is do not need. So in order to solve these problems, or in order to handle this type of the problem, a nature-inspired algorithms come into the existence. Okay, so what is the specialty of the nature-inspired algorithm? There is no need of the derivative. If somebody is from the non-mathematics background and they have don't knowledge about the how to calculate the first, second derivatives, then there is not a big task for the nature-inspired algorithm. Second, objective function is definitely a non-convex or convex. There is no issue. Okay, either objective function is x square, x cube, sine inverse x, whatever is there. The same type of the methods are applicable for the nature-inspired algorithms. So what is the overview of this nature-inspired algorithm? That is, nature provides some of the efficient way to solve the problem. All of you see that a flocking of the birds. Okay, fishes in the pond, they are all moving in a group. Okay, yes. The ant is moving in the road, they are all moving in a group. And if one is diverting their path, all are diverting their path, while in the same direction. Okay, it is not possible that if some ant is moving in the right hand side, then the other are moving on the left hand side. All are moving in the same parallel directions are there. So these are the nature-inspired algorithm. And same we have seen in the birds. Birds are flying in the sky. Okay, if they are moving in the same horizontal direction, then they are moving in the same horizontal direction. If some obstacle is there, okay, in front of the birds, then they divert their pathway, and they all are diverting their pathway in the same direction. Okay, so these type of the algorithms which are inspired by the mathematician, engineers, and all those economics persons, and they create the nature-inspired algorithms. That's why we call as the nature-inspired algorithms. That is, we are inspired from the nature's behavior of the birds, behavior of their ants. Okay, if we are inspired from the ants, then we call as the ant colony optimization. If we are inspired from the swarm, then we call as the particle swarm optimization, and so on. Okay, so what type of the problems we have to solve by using these nature-inspired algorithms? That is, there are so many problems. Like say some structure engineering design problem, some turbine problems are there from the mechanical point of view, some chemical engineering point of view. They have created some new design, and they want to say the diameter of this is up to the 5 centimeter, up to the 5 millimeter, and then so on. So some structure engineering design problem, some decision making problem. What is the decision making problem? Suppose you go to the market and buy a mobile phone. Okay, so what are your options? You go to the first shop and take it that mobile phone is 5,000. Second shop then the mobile phone is 4,900. Third is 4,800. And then last one is for the option online. It's take a 4,000. Okay, then you ask for the expert. Ask your friends, ask your parents, which one is the best one. Somebody say fourth is the original market price is 5,000, but in the online is say 2,000. You say no, it may take some illegal is there, or it may take some defective pieces and so on. So this type of the problem, that is the decision making. You have to take a decision so that one simple more example in our day-to-day life. Okay, that is you go to the you want to purchase a house. Okay, what are the features you have to see in your house? What is the good location? Okay, parking facility, security point of view, and all that. Okay, then you have to create a matrix. One is from the parking, okay, facility, security, children parks, okay, and then so on. And there are the houses are there. House 1, house 2, house 3, house 4, and then rate them. For the house 1, you say there is a security is 50%. So you take a 0.5. Okay, then you have to see a children park facility is there. If there is no children park facility, you take them there 0 rating number. Similarly for the second house, then observe these factors are there. Then you have to take a decision which house you have to choose depending upon these parameters. So that is the decision making problems. Okay, and definitely the reliability optimization problems. Maximize the budget, maximize the profit, minimize the cost.
The meaning of the reliability is quite different. That is the hazard function and
hazard functions.
yeah, how
Okay,
would we correlate that?
that is reliability is totally depending upon the hazard function.
Okay, 100%.
So if I say our function is constant, that is exponential function, then the reliability is depending upon that. But in our day-to-day life, it's not an easy to calculate the hazard function. So we usually take the Weibull function. Okay.
Function.
So Weibull is bathtub. So bathtub is always represent that because like say I just want to buy this marker newly, then the length, the life of this marker is 1 hour for the first for the newly product B. After that it is slow down, okay, for the next 1 hour, and after that it decay that. Okay, so the graph is U shape, bell shape curve. Firstly is high, then decreases, then constant, and then that is a peak level. So that is a bathtub. So if your curve, if your intention, if your reliability problem, like say sugar industry, initially you are taking that your product is as good as new, then your production is definitely quite high. Then your production is increasing. After that, after the 1 year or 2 year, if maintenance is not be there, then it's a constant is there. Okay, and after that, the decay, that is the replacement is there, repair is there. So this type of the problems you have to manufacturing. Okay, so this type is dealing with the reliability optimization problems. Basic task is to in that reliability is to there are the different components in the different components in the plant. Okay, like say sugar industry, yeah, paper mill. One is the washing unit, there is a paper production plant, and then so on. And how to combine that is based on the reliability components are there. Then this is the basic nature inspired algorithm for the optimization. That is any computational intelligence that is based on the intelligence program. So these are divided into 3 parts. One is the nature inspired algorithms, second is the fuzzy logic, third is the neural network. Have you heard about these 3 words yet before? What is the fuzzy logic system? What is a fuzzy set? Have you heard about the fuzzy set?
That something is red or red not.
Yes, something is red or red not be. If I say the length of this marker is 5 centimeter, somebody say yes or somebody say no. Okay, but if somebody say yes, what is the meaning that the length of this marker is exactly 5 centimeter? If you say yes, what it means that if I say the length of this marker is 5 centimeter, you say yes, what it means that the length of this marker is exactly 5 centimeter. Is it true? May or may not be. But you say yes, the length of this marker is 5 centimeter. Then I say how much you are confident on that. You say 80% is confident that the length of this marker is 5 centimeter. So means your opinion, your decision is 0.80. In terms of 80% is 0.80. Okay.
The row is red.
So row is red. How much is red? I say honest is there. I am honest. You are honest. Okay. So how honest you are? How beautiful you are? Okay. So honest is a linguistic word. Okay. You can't define that. So for that, a fuzzy logic is defined. There is a 2 terms, that is a crisp as well as the fuzzy. Crisp means yes or no, like say Boolean, either 0 or 1. But if instead of the 0 and 1, if somebody say 0.45, there is a 45% he is sure that he is honest. Okay, it may that I am honest from my point of view, but I am not honest from your point of view, or I'm honest from the third point of view, but fourth point of view, I'm honest, but I'm not 100% honest. I'm the 60%, I'm the 20%, I'm the 25%. So that number which lies between 0 and 1, which rating between the 0 and 1, and that type of the theory is dealing with the fuzzy set theory. Membership function, that is called as the membership function. In our Cripps theory, in our Boolean theory, we call as the characteristics function. Characteristics function is called as the either 0 or 1. If I say all this in front of me, you are the 6 candidates. Okay, if I say say Rajan is there, if somebody have the Rajan name, okay, so if I say Rajan is present, if out of 6 students you say yes, my name is Rajan, then the membership function is 1. If Rajan is not there, the membership function is 0. Okay, so that is a Cripps set theory. Or if somebody say my nickname is Rajan also, somebody's called me as a Rajan in the one time. Okay, in my childhood, in my college, somebody say Rajan is your nickname. I just put up your name as a Rajan. Then how much time you call as a Rajan? So 0.25. So that is a fuzzy set theory. That deal with the, instead of the 0, instead of the 1, they have the number which are lies between 0 and 1. That is called as the fuzzy set theory. Okay, that is called as the membership function. What is the neural network? Because I am talking about the nature inspired algorithm. So that's why I'm just give you a brief idea what is the fuzzy logic system. Okay, and what is the neural network? What is the neural network?
Neural networks that make a line in your mind related to the neurology, and it is showing the remembrance power of the mind.
Of the mind, that's true. Like say you pinch in your hand, right? Then the signal come in your body and goes to your neurons in your brain with the help of the neurons. So what is that? You pinch in here, okay? So something is transferring from here to here. That is the weight transfer. Okay, so in the neural network, you have to train the weights from your input to your output. Okay, so that is a prediction. You have to pinch here, you have to something do that. Then what's the signal in your mind? Okay, they are transforming from the one place to the second place or the third place. That is with the help of the neurons. So the theory which are the logic behind this one is that one. So this is called as the neural network. So in this neural network, we have already trained the weights. Our target is to train the weight so as to minimize their targets. You have to minimize their error. If I say my target is to achieve this one by the budget of 1 crore, but it is not always possible that. Okay, it may have, you may achieve over the 1 crore or you may have below the 1 crore. So your target is to minimize the error. Okay, so that is the root mean square error or the weightage functions are there. So today I'm here to discuss about the nature inspired algorithms. So okay, now the nature inspired algorithm is again divided into the 2 categories. One is the evolutionary algorithms and second is the swarm optimization. Okay, firstly swarm optimization. This swarm optimization is inspired by the nature. All are inspired by the natures, definitely. Okay, like say this is the particle swarm optimization. This is the depending upon the flocking of the birds. Okay, so movement of the birds. Ant colony, like say as we discussed earlier, this is the movement of the ant are there. Genetic algorithms, differential evolution, this is the genes. Like say husband, wife, and then parents are combined, then new offspring is there, like in the form of the children's. Okay, so this is a genetic algorithm depending upon the genes. Okay, and similarly for the differential algorithm. So these 2 algorithms, evolutionary algorithms as well as small are depending upon the nature inspired algorithms. Now what is the meaning of this flow chart is there? And definitely there are many more are there. One is the artificial bee colony, which are depending upon the bee. Okay, one is simulated annealing. Okay, and so on. Now what is the evolutionary algorithms? Okay, so before this slide, these are individual, population, fitness function, that is the objective function. Your target is to maximize f of x. Okay, so in the evolutionary algorithms, instead of we call as the f of x, we call as the fitness function. Like say our objective function is f of x is x square plus 1. So x square plus 1 is my objective, that is a fitness function. Okay, and my solution vectors, that is x1, x2, x3, x4, that is called as the individual speed, that is called as the population, and then so on. This is, I just come to this slide. Okay, but before that, this is the picture of the evolutionary algorithm speed. That is, this whole circle is my population. Like say NITTR is my population. Okay, and you are the part of this population, you are the part of this NITTR. So it means you are the individuals. Okay, NITTR is my population and you are a part of this one. So this is called as the individuals. Okay, and based on these individuals, take any two, randomly pick. Okay, it may take this one, okay, or it may take this one. Choose any two. Okay, and these two is called as the crossovers. You have to mute them. Okay, एक हमने 1 लिया, एक का 2 लिया, दोनों को मिला के it may take 1 multiply 2 कर सकते हो आप, 1 plus 2, 1 divide by 2, even 1 2 को combine करके आप 12 बना सकते हैं. It's a 12, 21. Okay, 1 की power 2, 2 की power 1, and then so on. So how to combine that? That is a crossover. Okay, so after the crossover, that is, one is the female, second is the male. These two individuals have these two circles. Okay, one is the parent. Okay, so after combining, okay, and then offspring, there is a new product is generated, and in evolutionary algorithm we call as the offspring. Okay, so what is the speciality in this offspring? They are definitely depending upon their parents. Okay, and their genetics are same. So this is called as the mutations. Like say this is there. Okay, so this, all these terms, that is the population, this is the individual, this is the crossover, this is the mutations, and so on. This is explaining in this slide. So that is the basic terminology which I have used in the evolutionary algorithms. First one is the individuals. It carries of the genetic information. Genetic information on chromosomes. Okay, that is, it depending upon that. Either your searching space is discrete, is a continuous, is a boolean, or it's a mixed. If I say it's my discrete number, it's my boolean number. So your chromosomes are like say 0, 1, 1, 0, 0, 0, 1. Okay, like say if I say my number is, integer number is 8, then you can easily transform from the binary to the hexa, hexa to binary, okay, and so on. So that is, in our simple optimization problem, if I say x is my solution vector, which are depending on the lower and upper limits. So in that case, in the evolutionary algorithm, we call as the individuals. That is, it is characterized by its state in the searching space. That is f of x. So x is my individuals. So population, there is a pool of the individuals. If I say x1, x2, x3, there are my 3 individuals. Combine all these xi's, we call as the populations. Okay, so population definitely a bigger thing. Okay, or moreover, in our statistics, if you know about the statistics, there are 2 terms. One is the population and second is the sample. Okay, so population is the bigger thing and the sample is a subset of the part of this one. So same thing for here. Okay, so based on these individuals, okay, that is x1, x2, x3, you have to calculate the f of x, and that f of x is called as the fitness function. The term fitness function is used for the objective function. Instead of we call as the objective function f of x, in the evolution algorithm we call as the fitness function. And the generation. Then the time unit of the evolution, EA, is called as the evolutionary algorithms, and iterative steps. Iterative steps means, like say I am here and I want to move from Patiala to, from Chandigarh to Patiala. Then there are different ways. Okay, one, I just firstly go to Ambala and then go to Patiala. That is a one step. Okay, second by Jirakpur and then so on. Okay, and similarly for the other ways are there. So we are moving from step to step, like say from the Patiala, from Chandigarh to bus stand of the Chandigarh. So this is the one step. Okay, after that I just rotate myself to some other direction. So this is the second step, and then so on. So this is the time unit of the evolutionary algorithm. Time unit is nothing means the 1 hour, 2 hours. That's just stepwise, iterative. Like say in the numerical analysis, we always use a regular falsy Newton method. We use a stepwise procedure are there. So same thing here. This is the iterative step. Iterative steps clear. What is the meaning of the iterative? That is the one by one. Firstly, something is there, and we have to improve the previous values with the help of the new information.
Iterative method we use in the numerical analysis.
Iterative methods we have used in the numerical analysis. That is the same thing is there. Same procedure is there. Okay. So the iterative steps of the evolutionary algorithms. So these are the basic terminologies we have used in the any of the evolutionary algorithms. Either they are the particle swarm optimization, either they are in the genetic algorithms, either in the ant colony optimization. So this is the simple picture of the evolutionary algorithms. Now, what are the features of the evolutionary algorithms? So this firstly slide is the what is the terminologies we have used in our evolutionary algorithms, because this is the evolutionary algorithm. This is not particularly for the genetic algorithm. This is not particularly for the particle swarm optimization. This is common for all the evolutionary algorithms. And this is the picture how the evolutionary algorithm works that, and what are the features of the evolutionary algorithms. First one is how to select, because in that slide I just say these two circles, that is parents, one is a male and female are there, for example. How to pick these two candidates are there. Okay, either you can take randomly, that's two. Okay, or any other options are there. We can assign some probability values. Okay, and then choose that which one is the highest. Like say I'm just put up a small test, okay, in front of you, and then find which one is performing better. Okay, and then I just check their IQ levels of the students. Then I just pick the two candidates which got a highest marks. Okay, so one phenomenon is there. Second, I can pick up all those students which are performing on an average. Okay, and even I can choose the two students. One is the best, okay, and second is on an average. The worst is there. So depending upon that, so that is the selection procedure. So that is a route wheel that is based on the probability. If I say x1, x2, x3, x4, x5 are my 5 elements, assign some probability values based on their behaviors, and then choose which one is the highest one. If you need a highest one, okay. Steady state, that's a constant, and so on. And that is a constant state, same. There is independent of the time factor, fixed value. And what's the selection procedure, and what's the functioning of this selection? Why we use this selection? That is to motivate to preserve the best value. Okay, if I say out of these 4 candidates, if I say this candidate is the best one, okay, then out of these 2 candidates, this is the best one. And then I just compare these 2 best ones. Okay, which one is best, I just pick up and then stand here. Then for the next group, again I just pick this best one, compare that best one with the second best one, and again best one, find it. That is preserving the best nature of the solution. Second is the crossover. Okay, so which crossover I use? In this picture, I have used the parent. I just combine these two, male and female. Okay, then this is procedure is. Then the problem is which crossover you have to use. There are different types of the crossovers: 1-point crossover, 2-point crossover, and so on. And what's the functionality of this crossover is to create a new solution. Okay, like say 1 and 2. If you pick up the two numbers 1 and 2, then what's your task? Either you can use 1 plus 2, 1 minus 2, 1 divide, 1 की power, and then so on. Okay, so it create a new solution, because if you take 1 plus 2, then the new is 3. Okay, if you take 1 multiply 2, it's a 2. Okay, it's 1 divided by 2 is 1.5, and then so on. So it's create a new solution by considering more than one individuals. Okay, so the procedure you have to choose depending upon the U. Okay, and it is helpful for finding the global search. Okay, and if you find 1 plus 2 is there, 3, and compare the previous value. Okay, if I say my problem is to maximize that, for example, simple example crossover is if you pick up the two numbers 1 and 2, okay, and your target is to maximize that. Okay, so if you take 1 divided by 2 instead of 1 plus 2, if you take 1 divided by 2, the number is 0.5, but 0.5 is not bigger than the 1 and 2. So it means 0.5 is left out, then the new numbers are same, still 1 and 2. But if you take 1 plus 2, then the new numbers are 3. Okay, so 3 is better than the 1 and 2. So the new numbers are, previous number is 2, because 1 and 2 mein bigger number is 2. So the new number is 2 and 3. Okay. Then again perform some operations, 2 plus 3, 2 divided by 3, 2 multiply 3, and then so on, and find the new best one. Okay. So that is for preserving, for finding the global search, and hopefully for the better solution. Because if our target is to maximize, then we find the new solution, otherwise replace that. And the last factor is the mutation. Okay, so you can choose a randomly, okay, based on some polynomial probability and then assign. So its target is to keep diversify in the population. Like say in this number, say 0, 1, 0, 1, 1, 0. Okay, so I just replace, because this is a binary number. Okay, so I just replace this second last one, this second last number 1, this 1 is replaced by 0, because this is a binary number. So 1 is replacing only with a 0. Okay, so 0, 1, 0, 1, 1, 0 is replacing with the 0, 1, 0, 1, 0, 0. Okay, if it has some particular number like say 1, 2, 3, 4, 5, 9, you can replace 3 with any of their number like say 7, 9, and then so on. So definitely genes are totally changes are there. So this is the mutation system. Now, so swarm intelligence. Okay, so as we discussed, swarm intelligence is based on the behavior of our natures. Okay, so swarm intelligence is an artificial intelligence techniques which are based around the study of the collective behaviors. Okay, which are totally based on our behavior, like say ant, birds, fishes, and so on. Okay, so swarm intelligence are made of the populations. Okay, because this is the principle of the evolutionary algorithms. One is the population. Based on your population, choose the individuals, that is called as the chromosomes. Based on that chromosomes, you have to calculate the fitness function. Okay, and based on that fitness function, find the best value, preserve that, update the values as you did in your numerical analysis. Okay, and then do that. So the example of these systems are like say nature's ant colonies, okay, bird flocking, animal herding. You see in your National Geographic channels or in somewhere, like say ships are there. Ships are always working, moving in their group. Okay, so bacteria, as for the biotech students, if somebody say, and the fishing school, if somebody see in the fishing, they are all moving in the same directions and so on. So what are the steps which are moving toward the computational principle? As we discussed earlier, that is, firstly, find the present position where you stand. I am standing here, okay, and my target is to reaching at this point. So what is that? You start from here, either go this side, okay, then go this side, then go this side, then this side, and ultimately go here. Okay, this is the one way. Second is start from here, directly reaching at this point. So which one is the best one? Your target is to find, if your target is to minimizing time, okay, then the shortest path is there. If your target is to cover all those cities as much you can within a 1 period or within a 1 hour, and then so on, it depends upon the constraints. So firstly, evaluate your present position where you stand. Okay, then second, compare it with your previous position. Okay, previous best, पिछला पुराना कितना अच्छा था, and the present position, आप इसके अराउंड में कितने बेस्ट हो आपके पास भी. Okay, and if you find a better one, replace that, otherwise keep preserving the previous value. That is my third point, intimate selves and others. If you find a better position with respect to the previous, replace your position with the previous value, otherwise keep preserving in that direction. Okay, so these are the three basic terms which I have used toward the computational complexity or the principles. Okay, now, so there are two basic terms which I've used in our swarm intelligence or the computational intelligence. One is called as the exploitation and second is the exploration. As says that preserving the good solution, because once we find the good solution and if we remove that solution, then it's a big task for finding again the best solution. Okay, so preserving the good solution. Okay, as we discussed in our previous slide, there are the three basic principles. One is the selection, then second is the crossover, and the third is the mutation. So out of these three, selection operator is used for preserving the good solution, while for the exploration, that is searching for the promising solution, that is finding the better solution. So how to find the better solution? You find the crossover and the mutation. Like take the two values, find plus, minus, multiply something. If you find the better, okay, that is a crossover. That is for the exploration. If you find the better solution, preserve that. So that phenomena is called as the exploitation. Okay, so excessive exploration is a random search, and excessive exploitation is the premature. Premature means पहले convergence से पहले आपको पहली चीज मिल जाती है कुछ. So I'm just explaining step by step what is the meaning of the particle swarm optimization and how they work with the help of the illustrated examples. Okay, one by one आप चाहे कॉपी पे भी कर सकते हैं exactly. One by one आपको exactly one by one steps से आपको clear करता हूँ. So particle swarm optimization as is proposed by James Neddy and the Russell Everts in the 1995, inspired by the social behavior of their flocking birds or fishing school. Okay, and their target is to minimizing the function. Moreover, you can maximize the function also. Okay, if my function is minimization, then you can easily convert to the maximization by taking negative sign, or you can take 1 by f. Okay, reciprocal of that function is maximization to minimization and minimization to maximization. And the phenomena that is the which are behind this particle swarm optimization is each particle is treated in the searching space, that is a population, which are flying because they are inspired from their fishing school as well as the bird flocking. Okay, so they are flying. So how they fly? Based on their previous experience. Okay, so based on their one is that based on their own flying experience, if some bird is new, okay, then they are not confident to fly as good as the others will be. So one is flying based on their own experience as well as flying of their experience of the other particles. If somebody is moving that direction, then other are also moving that direction. Either they know the path or not. So there are two basic terms. One is called as own flying up, and one is the other experience. Okay. So this is the basic model. This is the basic PSO model. So each particle is flying, okay, with the current position, because our algorithm is where you stand. What is your initial position? Okay. Second is the current velocity, and the current velocity, this VKI, this is my velocity, current velocity, where you are stands. So this velocity is depending upon your previous velocity. This is my K plus 1, that is the iterative number. You are standing at the first position, then what's after the 1 years, you are reaching at some point. So that is K plus 1. So that is the previous value. And this PKI is my best position. XI is my initial. PG, here G, this G is my for the global best. This is my local, personal and the social are there. Now how they works that? In that case, R1 and R2, they are the random numbers. You can take 0.4, random number lies between 0 and 1. You can take any value, 0.4, 0.5, 0.91, whatever is there. Okay, and C1 and C2 are the some parameters that is called as the acceleration constants. That is, you have to fix that. Okay, now how they works that? So I just giving you a simple one by one procedure. Okay, so basically initially define your current position, because see in this slide you need one is PKI. Okay, what is the previous best value? XKI, your initial position. Okay, PKG is called as the global best. Out of the positions, all those positions, which one is the best one? And XKI is the present position. Now see, look at this slide. Okay, this one. Now, so assume that your current position is 4,2. This is my x-axis and y-axis. Okay, so this is my current position. This is my 0,0. Okay, so this point is my 0,0. So this is my 4,2. Initially you are at a point 4,2. Okay, and this blue is your particle best position. Like say you are the particle, then what's your best position? Okay, so this is my 9,1. Say 9,1. So this is graphically, this is my 9,1. And this is my target. This is my global optimal. Okay, and this is my 5,10. So what's your meaning? You are here and your target is to start from here and reaching at this point. So what are the various ways? Either you can go here, okay, then here, then here, then here, and then reaching here. Okay, either, or you can go from directly this to this, okay, or you can go from firstly this side, then this, then up, then down, then this, like say zigzag motion out here. So firstly you have to give some initial velocity. किस तरफ आप जाना चाहते हो? Okay, so I just assume that I'm just giving my initial velocity in that direction. Okay, my target is to starting from this black dot to this red one. Okay, so I'm just giving in that direction. So my velocity is minus 2,2. Okay, I'm just talking about the two-dimension picture, x1, x2. So I'm moving in that direction. Okay, so now what is the meaning of this minus 2,2? Look at this again, my previous slide. This one, this number. This is my first one. Velocity is my minus 2,2. Okay, now pki and x, this one is c1 r1, okay, into pki minus xik. So what is that? So see at this slide, sorry, this slide. So this is my pki, p best, okay, minus initial position b. So p best is my this blue color, okay, because this red color is my global and this is my local b based on their on flying experience. Okay, so pki minus xi. So this p best minus xi. So how you calculate the distance between the 2 points p? X2 minus x1 whole square plus y2 minus y1. That is the same distance p. So I'm just using the including distance p. So this blue dot is my 9,1. Okay, so this is my 9,1. Blue is my 9,1 and the black is my 4,2. So the difference is my 5, minus 1. Clear? And for the global best, so that is this black dot to this red, that is for the red color. That is my social, that is a complete population wise. So this is my, this red dot is my 5,10. Okay, so 5,10 minus 4,2. That is my 1,8. Okay, so what is that? This 1,8 and 5,1 is my, this number. This number. This bracket term be pki minus xki, okay, and pkg minus xki. So now the equation 1.4 becomes, this number is my minus 2,2, okay, c1 and r1, they are the random numbers, you can choose that. So I just choose these two numbers as this one. So I'm just choosing c1 and r1 to be a 0.8, combine that, and c2 r2 is my 0.2. Okay, so vk plus 1 is my vki velocity plus previous position velocity and the next position. So after this one you get 2.2 and 2.8. Okay, so graphically what is the meaning of this one be? Initially you are moving from this to this, okay, that is from the minus 2,2. Now your new position is 2.2, 2.8. So means on the x-axis you are moving at this point. Okay, your target is here. Remember that. Starting from this point, now you are here. Okay, so the best velocity is, so the update velocity is your previous velocity. That is the previous, this is my previous position plus the next one. So this is my previous position is 4,2 plus the new one is, so 6.2 and 4.8. So this is my new update solution. Okay, so now there are the two chromosomes B. There are the two points B. One is my initial, that is this black dot is my 4,2, and the new update is 6.2 and 4.8. Okay, compute the fitness value, compute the objective function value at this point. Which one is the better in terms of the objective function, either maximization or minimization? If you find the new one is best one, preserve that, okay, and then forget about the initial value xk, okay. If you find the initial value is best one in terms of the objective function, then the forget this 6.2 and 4.8, okay, and the process is repeated term by term, that is iterative ISP until you reaches at this point or near to this point, because this is a global solution, okay, then you can't easily find this exact value, so near about this one.
If we want to maximize the thing, then we can consider the
Highest value of the objective function, highest value.
Consider to the objective function. If we are consider the lowest value and we are getting the highest value, then we consider this value. Our objective function is minimized, right? In that case, we consider the lowest value.
For example, I should say
Best solution.
for best solution, if I say my objective function is say x square plus y square, simple, okay, or you can say x1 square plus x2 square, okay. So what it means, at this point initial position is your xk, so your number is 4,2, so this is my x1, first x4 is my x1 and 2 is my x2, so x1 square plus x2 square, that is 16 plus 4, 20, okay. And at this point, this my first number is 20, and then for the second 6.2 square plus 4.2 is square, okay. So iska kuch ek number aayega, compare 20 with this one, okay, that is higher than 20. So if your objective function is maximization, then your new position is 6.2, 4.8, okay. If your objective function is minimization, then forget about this 6.2 and 4.8, keep preserving 4.2, 4,2, okay. I'm just showing a detailed procedure how to calculate that in our after this session also, okay. After the tea, I'm just giving one more lecture, okay, one by one calculation on the blackboard also. There is no, don't worry.
It's a new subject, new topic, and we are keen interested in that.
Yeah, definitely. It's one of the highly cited, okay, research from the researching point of view as well as from the own personal optimization point of view. This is a particle swarm optimization is one of the beautiful subject, one of the beautiful and the fast growing challenging work is there.
So do you have any ebook regarding the?
I can mail you. Don't worry. I just provide you my email ID.
Yeah, I have.
You can
already
take-
written your mail ID there.
You can use this PPT. Okay. After this session, after the tea, I'm just giving you one numerical example. Here, in this case, 6.2 and 4.2 is very small data. I'm just giving you five bunch of the data and solve on the blackboard. You can do that easily understandable. Don't worry about this one. Okay. Okay. So now this is my movement. Okay. So this is the mechanism of this one. जो अभी हमने ऊपर किया. Initially you are here. Okay. That is this circle. Say if I am moving initially in that direction. Okay. But if somebody say you are moving in that direction, but if I giving some weight is say 90% is 40% is something. So I just multiply with this omega, inertia. Okay. So initially you are moving in that direction. Okay. This is PKG is your global position. Okay. Forget about this one. Initially forget about this one. Okay. Initially this forget about this one. So this is your global. Your target is here. Okay. And this is your personal best position. Based on your experience, you say, I'm moving in that direction. Okay. But your target is to here. So initially you are moving in that direction. Okay. So velocity is this one. What's the difference? What's the distance between this and this? So distance between is the personal influence V. Okay. So I'm writing here because this is the parallel line. Okay. So I can write in terms of the vector. This one that is called as a C1 R1 PKI minus XKI. Then find the distance between the best position, global best, and this one. Draw the parallel line of this one. Okay. Just like say as we did in our vector quantity speed. Okay. So what is that? This plus this plus this. So you are reaching at some new point. So new point is my xki plus 1. So that is my equation number 1.5. Okay. So then 1.6 is my position updates because you are reaching at this point x, you are starting from xki and reaching at this. So this distance, okay. So initial plus the movement distance. So xki plus vki is my new updated equation. Clear? So 1.5 is my velocity updation and 1.6 is my position update equation. And in the particle swarm optimization, the 1.5 and 1.6 is the mechanism, is the procedure to solve the optimization problem with the help of this 1.5 and 1. Only 1.5 and 1.6 is required to understand the particle swarm optimization. There is no need of the partial derivative. There is no need of the first and second order derivatives is there. Particle swarm optimization, evolutionary algorithms, especially in this algorithm, I am just talking about the particle swarm optimization. So the particle swarm optimization is working only on the 1.5 and 1.6, nothing else. If you are able to calculate this pki minus xki and pkg minus xkg, then the particle swarm optimization is easy. Okay.
We deal with the particle swarm optimization for genetic algorithm.
The genetic algorithm is a separate.
Every algorithm
We can use that. In here, in the particle swarm optimization, the position, this is my position update. 1.6 is my position update.
We have decided some new and standard thing which thought we want to go there, and that process goes through by this.
Simple mechanism, particle swarm optimization. Like,
Please explain this geometry.
like say, in here, xki is my previous position. So what is the evolution algorithm says that as we say evolution algorithms is a stepwise procedure. You start from the initial point, reaching at the target position, not directly in the one step B, reaching this step by step B. So what is the step size B? There is a main task, how to choose the step size B. So that's the evolution algorithm says that. In the particle swarm optimization, this VKI, this 1.5 equation is called as the step size B. This says that you are moving in that direction or in that direction or in the straight forward. While in case of the genetic algorithms or in the artificial bee colony, ant colony, this 1.5 and 1.6 is changing. Okay, so mechanism or the procedure behind the evolutionary algorithm is same. You have to find the step size so that the previous position is updated.
We cannot go directly from that point. We are using these.
Because I say in our
If you want to go directly, we will be minimizing these steps. We can go directly by if it is possible.
directly from initial to final. But how we know the final position? Our
It's decided that, right? That we have to reach that position or maximize or.
if I say my objective function is x square plus 1 plus sin x and then so on, what is what's the optimal solution? We can't know. How we know that? Then we have to move step by step. Okay, and after the 20th iteration, 50th iteration, we see that the previous value and the new value are same. Then again the previous value and the same value are same. What it means that we are reaching at the optimal solution. Because our objective function is x square plus 1, then you can easily find the optimal solution. But if my objective function is very complex, okay, then you don't know what's the optimal solution. Because if we have the optimal solution, then why we use the optimization technique? Okay, so in order to find it, okay, we use step-by-step procedure and then calculate it.
Excuse me, sir.
Yes, please.
So there's a question. What is this W signify here?
Yes, I am explaining that.
Okay, thanks so much.
Okay. Now what's the significance of the W? Okay. So now W is my inertia. That is a weight vector which are giving to the velocity. If somebody say I am moving in that direction, okay, but how confident you are in that? Somebody say no, you are not moving in that direction B. Okay, so you say no, I am going in that direction B. So it means you are 100% sure that you are going in that direction or not B. If somebody says no, I am not sure about the 100% is B, I am giving some weightage factor to that velocity B. I am giving some 20% is there, some 90% is there, that my initial direction is true. Okay, so that vector is called as the inertia. Okay, that is called as the omega. That W is there. Okay, but choosing this W is really a big task. Okay, that come in my next slide. What is the physical significance of this inertia weight vector? That is comments on my inertia weight vector. The large inertia weight facilitates the global search. Okay, and definitely the omega lies between 0 and 1 because it's a weight vector. So weight vector 0 means 0, 1 means the 100%. Okay, while the small inertia vector facilitates the local solution. Like say maybe that you are moving in the x direction, okay, and your optimal solution again is in the x direction, but you are giving a 10% weightage on that, okay, and after that you are moving in the opposite direction. So it may take the local as well as the global solution. So choosing this omega is one of the biggest tasks. Then the task is how to choose that. The major goal is how to choose this omega or this W. So the basic rule that mostly the researchers have followed, that is they are increasing or decreasing with respect to their iteration number. Like say, initially I just fixing my value to be 0.9, 90% is weightage to my initial position B. I'm moving in that direction to be the 90% B. But I'm also saying that lowest to lowest or worst to worst, I'm just giving to the 40% weightage only. That is my highest number is 0.9 and my lowest number is 0.4. And there are infinitely many values which are lies between 0.4 to 0.9. How to choose that? So it is choosing based on your equation numbers. So equation numbers means you find in the first direction that 0.9 is my first one, and after the experience you see 0.9 is the correct number, 0.6 is my correct number. So you can update with the help of your algorithms. So by linearly decreasing the inertia weight from the relatively large value to the small value. Large value is my 100% to the smaller number, you can assign that. It may be 20%, it may be 90%, 40%, it may be 30%, depending upon your need, depending upon your target values are there. And definitely the comments on their larger omega, larger W is greater global search availability, okay, and the smaller number is greater lower searching availability. Also, if you say my lowest chance assigning to this W is 0.4, means 40%, but after the iterations you see that your number is below the 40, but your target is your choice is you don't go beyond the 0.4, then you can say the steady state number is reached. So you can assign minimum number is 0.4, 0.4, 0.4. Okay, if somebody say 0.3, you are not agreeing on that. Somebody say assign the lowest number to that, but what's your lowest number is 0.4, so you can assign 0.4, 0.4, 0.4. Now what are the factors? See, this omega, physical meaning of this omega. Now what is the physical meaning of C1? What is the meaning of the C2? What will happen if C1 is equal to 0? What will happen if C2 is equal to 0? Okay, now see, the constant C1 expresses how much confidence a particle has in itself. Now see expression 1.5. The C1 coefficient is assigning to the pKi. Is pKi is global or local? Is pKi is global or local? pKi is local. Local means if you are the particle, okay, then pKi is your best position according to you. Okay, individual person की best position है. But if in a classroom there are 100 people, okay, out of that 100 people there is a one maximum value that is called as the pKg. But each individual student has their own maximum and the minimum value. Okay, well, minimum value or maximum value means their IQ level, for example. Okay, so every student, each student has their minimum IQ level and the maximum IQ level. Everybody know that I am able to understand this concept up to the 40%, and the maximum to maximum is 70%. Okay, so pKi is for the individual, that is for the itself. So that's why this C1 express, the constant C1 express how much confidence a particle has in itself. Okay, you giving a number C1, like say I just assigning C1 to be a 0.3, means you are 30%. Okay, so how much confidence a particle has in itself. While C2 is assigning with the, see the equation 1.5 again, C2 is assigning with the pKg. Okay, so C2 is itself defining for the C2 express how much confidence particle has in their neighborhood. Okay, like say if one candidate say I am the intelligent person B. Okay, so in itself they are intelligent B, but with the comparison of the other students, so how confident they are intelligent B. Okay, if I say I am the confident, okay, with my neighborhood persons, I am confident, I am intelligent with myself, that is for the C1. Okay, but how I am confident, I am intelligent with my neighborhood person or with my classroom also. So that is represent for the C2. Okay, so these are my global as well as for the neighborhood position. So what will happen when C1 and C2 both are 0? So what's your 1.5 equation? If C1 and C2 are 0, then what's your 1.5? What's the value of the velocity? Only W into V ki. That is, the particle is moving, the particle is flying with their own initial velocity. But if they are moving in that direction, okay, so they continuously moving in that direction. There is no obstacle in behind that. Okay, so same factor. If C1 and C2 are 0, so the particles are keeping flying at their current speed. There is no obstacle behind that. There is no direction to moving to change their directions. Okay, so particles are keeping flying at their current speeds until they hits at the boundary. Until they hits at the boundary. On the other hand, if C1 is greater than 0, that's a positive number, while C2 is my 0. C2 is my 0 means neighborhood is 0. So the particles are independent. Each particle find the best position in their neighborhood by replacing their current positions. Similarly, for the other hand, if my C1 is 0, C2 is non-zero, so means individual itself की position value 0 है आपके पास पूरा factor, so all are depending upon their neighborhood. So the entire swarm is attracted to a single point, that is PKG or PG. That is my 1-point equation. There are the 4 factors. One is W, C1 and C2. R1 and R2 are the random numbers. You can assign 0.4, 0.5, 0.9. That is not a big issue. R1 and R2 are the random numbers because we assign some numbers because in that one. See, this is my the distance, okay, and this is again this is a parallel line. Okay, so you have to assign this multiply because C1 is the acceleration coefficient B. So to make a dimension matching that, because all of us know that length can be added into the length. Length can't be added into the mass B. So this factor C1 is the acceleration coefficient B. So this is the position. Okay, so this is a velocity. So you can't add that B. Okay, so to make a number which are measured dimensionless quantities there. So that's why R1, C1 is factor we have introduced that. Okay, so these are the two mathematician, or sorry, it's not a mathematician. These are the two scientists which are developed by Abbott and Nady in the 1995. A new optimization. This is the reference of this particle swarm optimization. These are the two scientists or ecologists which have developed their this particle swarm optimization. Okay. Okay. So after this T, I will explain you step-by-step procedure of the PSO. All these theories manually how you can solve. Based on that, you can create a MATLAB program. Okay. This is a basic overview of the particle swarm optimizations. Any doubt? Okay, so welcome all participants. So welcome all the participants. So this is my email ID. If in future, if there is any query or you want to share anything, okay, or you want to know anything related to optimization techniques for the swarm intelligence or from the mathematics side, or on the behalf of the Thapar University, if anybody wants some information from the Thapar University, from the research or from the PhD or faculty point of view, you can contact me at my email ID harishg58iitr@gmail.com, or you can go to my web page, okay, which is given in this link, okay, and you can find more informations related to my teaching, research, and my personal files are there. Okay, so can you continue? Okay, so now in this session, I am just giving you manual calculations how all these theory, that is the particle swarm optimization, works on that. So I just give a simple example, and if you want, you can do on your copies with step by step along with me, so that you can easily calculate all this procedure that is like say equation number 1.5 and 1.6, that is the base of this particle swarm optimization, and how the PSO will work in our day-to-day life. So now in this session, I'm just giving my step-by-step procedure of the PSO. So now assume that my objective function is f, and our target is to x1 is to maximize x1 square plus x2 square minus x1 x2 plus 2x1 plus 4x2 plus 3. Okay, and if in your own problems, okay, you can replace this objective function with your research problems objective function. Instead of this x1 square plus x2 square, you can simply take x1 multiply x2 plus sine inverse x plus logarithm, whatever the objective function you can take. Either it can be differentiable or non-differentiable. There is not a big issue. Okay, and my boundations are x1 and x2 are lies between -5 to +5. Okay, that is I'm only searching the maximum value within these bounds, -5 to +5. If x1 is say 7, okay, that is not tolerable with respect to this problem. So my objective function is again say maximization of f of x, and in particular this type of problem I assume that there is no constraint. Okay, now what are the PSO parameters? So as you know, the population parameters are C1 and C2. These are the basic chance. Okay, and R1 and R2 are my random numbers. You can choose 0.4, 0.5, whatever is there. Now the first of all, the population size. This is the main thing. Okay, so because from the population you have to choose the chromosomes, you have to choose the individuals. So I'm just taking a 5 for the sake of the simplicity. I'm just choosing the 5. You can easily create the MATLAB code for this one. If anybody need, you can drop a single mail, okay, with the reference of the IC3, today's reference. Just drop down a mail and asking me to send the MATLAB code of this program. Okay, I can send you. Okay, जो भी ICT 32 with the reference of this. Okay, ICT 32 NITTR Chandigarh. You can send me mail on my email ID. I can send you a mail of the source code of this MATLAB of this function, particularly for this function. So in this particular file, I am just choosing the population size to be 5. Okay, but in general, whenever you do in your research problem, this population size is at least 25, 30, depending on their problem to problem. Okay, and C1 and C2, because it is not a random number. Okay, this is acceleration coefficients are there. So I'm just choosing the 1.5, 1.5. For the sake of simplicity, you can choose 1.3, 1.5, 2.3, 2.0, whatever is there. Okay, and the maximum number of the iterations, that is up to within the 20 iterations, your target is to reach the maximum point, or you find the global point. If within that 20th iteration, after the 20th iteration, you are unable to reach the maximum point, then at the end of the 20th iteration, whatever your answer, that will be your global solution. Okay, so your foundation is you have to move only the 20 steps. After the 20 step, if you are able to find the optimal solution, or within the 20th iteration, you can, it may that you have to find the optimal solution after the 12th iteration. Okay, but it may be that you are unable to find the optimal solution of this particular function after the 20th iteration also. So at the end of the 20th iteration, whatever the optimal solution, whatever the objective function, whatever the solution vector, that will be your required answer. And dimension of the problem, this is a fix. Why we call as a 2? Because there are the two unknown parameters, x1 and x2. If I say my objective function is x1 square plus x2 square minus x1, x2, x3 is also be included in the objective function, then the dimension of the problem is my 3. Okay.
We get the number of iterations is 20. If we maximize it and we get the solution at 28th iteration, then we'll repeat up to 22 onwards.
No, we just make some command in the MATLAB. Okay, if we get the optimal solution, how we check the optimal solution is reached? We compare the previous value.
Number of iterations, if we want to know how number of iterations we get the solution.
There are two ways. The number of the iterations are used for stopping the algorithms. Okay, the other way is to compute the error. The previous value with the current value. take the difference, okay, and if you say 10 ki power minus 3, okay, if your objective last objective function value and the current objective function value is less than your error, okay, error is your demand, say 10 ki power accuracy, okay, so if that satisfies, then again you can terminate the algorithm. Otherwise the maximum number of the iterations are 20, 250, whatever is there. Okay, if in the research problem, I just tell you, whenever you are doing your research problem with the help of the any evolutionary algorithms, not from the particle swarm optimization, always choose a below 30 numbers, because if somebody is from the statistics background, always a reviewer, always the journal editor-in-chief ask for the testing, whether the results that came after the PSO algorithm, say 1.5, objective function is 1.5, then the opposite persons, either from the reviewer side, either from the editor board, or either from the editor-in-chief, ask you that, verify that your answer 1.5 is correct or not. How can you verify that? With the help of their sampling theory. So sampling is, that is testing purpose. So whenever your result is less than 30, number of iteration is less than 30, then you can easily use the t-test, f-test with the help of their sampling. So now dimension of the problem is my 2, because there are the two parameters x1 and x2. Now, first of all, the first step in our algorithm is to initialize the population, where you stand, what is your initial value, that is xi. So since my population size is 5, dimension is my 2, that is 1 is for x1, second is for my x2. So see, the first column, this 3.1472, 4.0579, this column is for my x1, second column is for my x2, and there are the 5 number of elements, there are the 5 rows, because my population size is 5. Okay, so 5 ranges are there. So if you choose a 50 population size, then this x is this number is 50 cross 2. Okay, so the first number is my x11, second is my x12, and so on. Okay, and how you this is not a random number. This is lies between -5 to +5. You can't take a 7.9. You have to create a random number between the -5 to +5. Okay. Now,
Dr. Saab, sorry to interrupt you. I have one.
Sure.
So, all the participants of different nodal centers as well as the offline participants. So, I have one announcement. Today, we are at the final session. So, we have decided to organize the validatory program at 2:30. So, all the participants, all the coordinators of different nodal centers. So, please connect Dr. Deepak, Government Engineering College. Dr. Deepak. So, there is a one announcement that today we have decided to organize the validatory function at 2:30 sharp, and possibility that you ensure that the presence of all the participants in your course, and there is a possibility that our honorable director or honorable HOD will be there. So please ensure that all the participants should be there in your center, right? At the validatory function. Okay. So I request all the coordinators at different nodal centers that we have decided our validatory function of this program will be held on 2:30 after lunch, right? And there is a possibility that our honorable director and honorable HOD will be there. So make sure that the presence of participant is mandatory. Okay, sir. Now you can. Okay. Thank you.
So now, since our population size is 5, so I have created 5 random numbers which are lies between -5 to 5. You can choose arbitrary numbers, any numbers which are lies between -5 to +5. Instead of this 3.1472, you can take 4.3457, any number, but it should lies between -5 to +5. Okay. Now, based on this evaluation, this population size, you can calculate the fitness function. Fitness function means That is the objective function. So now this is my x1, first column is my x1, second column is my x2. Okay, so substitute this 3.1472 is my x1, substitute minus 4.0246 is my x2, this number, this is my x1 and x2 in my this objective function, this one. Okay, x1 square plus x2 square minus x1 x2. So if you substitute this first line, only first line, that is 3.1472 square plus minus 4.0246 square minus xy, दोनों का multiply, okay, plus 2x1 plus 4x2 and plus 3. So you will get a number that is called as 31.9645. That is only for this 31.9645 is called as the fitness value corresponding to the objective function, okay, and whose domain vector is or decision vector is 3.1472 minus 4.246. Okay, I again repeat, there are two dimensions x1 and x2, that's why there are two columns. Okay, and our population size is 5, so that's why there are the number of the rows are 5. You can change your dimensions depending upon your problem. You can change your population size depending upon your need. Okay, so similarly this number 32.6168 comes when you substitute 4.0579 as x1 and minus 2.2150 as x2 in your objective function. Okay, similarly for the third, minus 3.7301 and 0.46822, then you will get 13.2971, and similarly for the 48.6753 and 41.4537. Okay, now what is your objective function target? Your target is to maximize that. Okay, then find the maximum value among them. Find the maximum value of the fitness function, that is come in the this red color. 48.6753 is my maximum among these 5 population size, and this is number 4th. Okay, this is population size. Okay, so 48.6753 corresponding to which decision variables be? So this is number 4th. So the corresponding x1 and x2 is 4.1338 and 4.5751. Okay, because you need pki and pkg as our seen our question number 1.5. Okay, so since the maximum fitness number is 48.6753 and the corresponding solution vector is 4.1338 and 4.5751. Okay, now is it 48.6753 is the maximum among all the population size, or is not a maximum among the population size? Is 48.6753 is a local or is a global?
It's a global, sir.
It's a global because this is the maximum among all these values be. It is maximum among all these values.
Yes.
So the global means this is a pkg. Global means this is pkg. So G means G best. So this number is called as the G best. Global best. Because 48.6753 is the best among all these population.
Yes.
If you take a 50 population, find the maximum among these 50 and then choose the best position. Now, is it your initial position or you have already do one step before that? This is my starting position. So what is the previous position?
Previous position is the last position.
Previous position is last position, but there is no last position. So it means there is itself a last position is again here. So since there is no previous iteration, so the personal best is same as that of this one. This is same. This is same as that of previous best because there is no best value we have so far.
So how would we got the value of the x, x1 and x2? How to calculate it? By the MATLAB or by the mathematics?
Okay, okay, you can,
How would we calculate?
how we can calculate, that is instead of minus 5,5, if you take a comma b,
Yeah.
okay, then the simple formula is a plus a random number. You can choose any random numbers between 0 and 1,
Formula you have.
b minus a. No, that is formula is not included in our slide.
Okay.
A plus a random number into b minus a. A and B are my,
B minus A.
this is my A minus 5, A plus R, B minus A. R is my random number. Okay, so minus 5 is my A is my lower limit, B is my upper limit. So lower plus a random number multiply with the B minus A. B minus A is my range. Yes, please.
If we consider another random number in this data, maybe we will get the more objective function is high and then this value.
Yeah, definitely, because
And
it's,
that will be more suitable exam. I mean value for that.
this is totally based on the random number.
How we are considering this is the best.
We are not saying this is the best B. We are searching for the best position B. We have to update all these values. Instead of 3.1472, we have to see that whether 3.1472 is the best or not. We have to update all these positions up to the 20th iteration. Okay. If we are still unable to find the best position, okay, we can stop that. Otherwise, go to the 21st, 22nd, and 30th iteration. Depending upon your need, depending upon your time, depending upon your complexity is there. Okay, now since there is no previous value position, okay, so our personal best is my based on my original value. So this is my, this one. Okay, and we need the initial velocity. Based on that, we move on that. So the initial velocity you can take either in terms of random number, lies between 0 and 1, or from the minus 5 to plus 5. It's again a random number. You can choose that, any one of them. Okay, so I just choose the random number between between 0 and 1. So again, A is my 0, B is my 1. So A plus R into B minus A. So by using this, we can calculate VEL, that is the velocity. Okay, now after this 1.5 equation works. Okay, that is velocity plus C1 R1 PKI minus XKI. Now see that. Now my first next equation. Since there are 5 populations, okay, so we move one by one. Okay, so firstly for my first particle means I have to update the equation, update this value. I have to check whether 3.1472 and minus 4. Yes,
Can
please.
you repeat how to get V?
Okay, sure.
How to get
Velocity.
how to get this?
How to get this velocity?
Yes.
Okay. Velocity is my random number which lies between 0, 1. Any number you can choose between the 0, 1, and again the size of this velocity is, because the population is my 5 and the dimensions are my 2, so it is my 5 cross 2. Any number lies between 0 and 1. You may choose any number lies between minus 5, 5. You may choose any number lies between 0, 7. You may choose any number lies between 7, 8. That is a random number lies between any 2 numbers. Okay, so for the first particle means I have to check whether 3.1472 and minus 4.0246 is the best value for the position for the particle 1 or not. If it is not, I can update that. Otherwise, I can preserve this value. So how can I update that? So see, for the first particle, for the first component. So this is my equation number 1.5. Okay, that is W velocity plus C1 R1. That is a PKI, that is a personal best. Okay, minus X. This 1 is my first particle, first component. So that's my 1 plus C2 R2. This is PKG, that is a global best, minus position. Now I just again assume that omega is my 0.9. You can choose any one of them. Highest value 0.90. 90% is there. What is the V11? That is the first component, first particle, first component velocity. So see, first particle, first component velocity is my 0.2194. Okay, so this plus, as my earlier say, R1 C1 is my 1.5. Okay, R1 is my random number which lies between 0 and 1. So here I use 0.5949. Okay, then this is a personal best. Okay, so personal best, see in the previous slide, personal best is my X. Okay, so P best 1 means X की value जो 1 है, तो x is 1 is my 3.1472. Okay, so see 3.1472 minus original position. Original and the p best initially in this case is same. So 3.1472 plus this is my C2. Okay, this is my R2. This again a random number lies between 0 and 1. This is my G best. So what is the G best? That is, you have calculated that. This is my G best. Okay, 1 1. That is the first particle, first position. So my 4.1338. So 4.1338 minus x11. Okay, so you calculate that, you will get 0.343240. Clear? Then the previous velocity x11. This is a new update velocity. Okay, so x11 plus v11. So initial x11, that is the previous velocity. Oh, sorry, previous position. So what's the previous position is 3.1472 plus v11. So v11 is calculated as 0.3240. Okay, so your new x11 is 3.4712. So is there any boundation on the x11? Between -5 and +5. That's our boundation, because our searching space is from -5 to +5. So check whether this x11 lies between -5 to +5. So it lies between. So you can take that value. Okay. If it is not, then come to the next slide. Okay. So this is my x11. Now for the similarly, for the now here I am for the first particle and the first component.
Beyond this limit -7.
I am coming to the next slide. Next slide may have. Okay. Now because there are the two dimensions. Okay. So again the first particle and the second component. The second component means V12. So for the V12. Okay. So again my equation 1.5 is same. Okay. So same calculation. Now this is my personal best is -4.0246. Okay, because for the second dimension, see in my original dimension problem. So this is my, because whenever you are working for the second particle, so all those values are coming from the second particle speed. Okay, so this means now, so the new value of the velocity is again same. This is my R1. Okay. And this is my R2, because these are the random numbers. You can choose any one of them. So C1 and C2 I have already fixing in the previous one. Okay, this is my omega is fixing by 0.9. Okay, V12 and then so on. So you get 9.46, 9.6414. Then by using 1.6, you get 5.6168, and it is beyond the -5,5. Okay, because our domain lies between -5 to +5. Now check whether 5.6168, this is beyond from the +5 side. So replace x12 with your upper bound, because your maximum boundation is 5. If somebody is apart from the 5, the beyond 5, you can replace with your lower and upper bound. And since this limit, this number exceeds from the +5, so I just replace x12 is my 5. Clear? So what it means, your after the first particle, after the PSO updation, only for the first, your initial value is, remember, your this number 3.1472 and -4.0246 now becomes, so now this number becomes this one. Okay. Okay, so your new number is my 3.4712, and now 5 is there. Same procedure you can do for the second particle first component, second particle second component. Okay, so I just give you one more slide. For the second particle, 2 1, second swarm size. Okay, second component, second particle first component. So V21 This is my omega. I just fix that 0.9. This is my 0.1908. This is my velocity. So 0.1908. So look at that in my previous slides. See, because we are working on the velocity. So this is my 0.1908. Okay. And if you just look at the previous initial position is 4.0579. So if you just update that, see, yes, you can change that in your algorithm. Okay, but yes, so take the same value 1.5, 1.5 is there.
We'll take the velocity also from -5 to 5.
Yes, you can take -5, random number between.
X we also we can from
X, you have to take X from the -5 to 5. Okay, you can choose velocity depending upon you.
and X is also
X is your domain. Domain is from -5 to 5. So you have to restrict on the X, but there is no restriction on the velocity. You can choose velocity from the, instead of -5 to 5, -1 lakh to +1 lakh, -1 lakh to 5 lakh, depending upon you.
we can consider equal also.
Equal also. Okay. So then the new velocity is 0.2016, and similarly for the position 0.42595, and it lies between -5 to 5. So there is no boundary conditions. Similarly, you can calculate x22 as similar to the x21. So you will get 2.9620, and again it lies between -5 to +5. So second particle after the PSO update becomes this number. Okay, and similarly for the third particle, because swarm size is my 5, population size मेरा 5 है, so this is for my second particle. Similarly for the third particle, similarly for my fourth, and then so on. After that, okay, so my swarm particles are updated. Swarm particles are there. Look at that. This like say first number 0.4712 and 5. So this is my this one, that is updated value. Okay. Now x2 is this is my new updated value. Okay. So my new number is this. Okay. Similarly for the third particle, this is 5. It means it goes beyond this one b. So you can replace with the +5. If it is gone beyond the -5, you can replace with the -5. Like say number is -6.37. So you can replace with the -5. Okay. If somebody violate on the left hand side, on the right hand side, you can replace with that values correspondingly.
If it is 6, then we can replace 5.
If you
If it is 6, then we can replace 5.
you replace 5. If you replace it is the -7, replacing on the -5. That is, it violates on the lower bound or upper bound. Replace correspondingly. Okay. Now the first iteration is complete, because you have to move on algorithm on the 20th iteration. The first algorithm is complete. First iteration is complete. After the completion, you will get this new position. Okay. Now again, replace the algorithms. Now the new chromosomes, new individuals are there. Based on this 3.4712 and 5, calculate the fitness value, objective function. Okay. You will get 49.6357 for the first particle. Okay. Similarly, whenever your x1 is this one, okay, and x2 is this one, that is corresponding to this line, you will get 37.669. Similarly for this one, third. Similarly for this one, and similarly for this one. Okay. And again, your target is to maximize the function, find the maximum among them. Okay. And again, you have to find the maximum among all these 5s. That is, this is a global. Okay. So the find the maximum is 57.4433. Okay. Now check whether this is the global or not. Compare this global with the previous global. 57.4433. Okay. Remember this value in your mind. 57.4433. What's the previous global best? So just look at that. Just wait. This is 48.6753, and our target is to maximize that. So it means we replace this 48.6753 with the new one.
That is a global value.
That is a global value, and correspondingly the G best, this number is automatically updated because we replace this 48 by 48.6753 with a new value. Okay, if instead of that, if instead of 57, that is a new value, okay, if we get 15 point something, then we keep preserving this global best value. Then we don't replace the new value with the previous value. Only we replace the previous value with the new value if we find the better value, otherwise not. Okay, so since our new value is 57 and it is better than the previous value, the previous is 48, so our and since this is my fifth number, okay, so the new global best is corresponding to the fifth value, minus 5 and 4.9377. So now the new G best is, now this is my new G best. Remember, replacing only if you find better value, better in sense of objective function. Objective function is my maximization, so that's why we're replacing that. Now global best is over. Now the second task is local, personal best P. So comparing each values, same. Now compare this G best, okay, this means you have updated value with the previous value, and we conclude that we get the better G best. Okay, as the fitness value is better. Better means because objective function is my maximization, so that's why we say the better. So replacing the old G best is my X4 with the new G best. So now for the future calculation, whenever we need the G best value, we substitute 5 and 4.9377. Okay, so remember that this is a note for you. If our new G best value is not better than the previous value, then carry forward with the previous value. Okay, again say better in the sense of the objective function. Now for the first particle B, now compare local wise B. Local wise means this one B. Here for the first particle, the number is 49.6357. Okay, what about the previous? क्या इससे पहले भी कोई स्टेप था आपका? Because this is the second equation. So compare this 49.6357 with your previous value B. So what's the previous value corresponding to this first element B? 31 point. Okay, so again the new value is better than the previous value, so replace the first position with the new value B. So that is, so look at the slide. So see, the previous fitness value is 31.9645 and the new value is 49.65, and again our target is to maximize that. Okay, so this number is this one. So compare the previous P value with the new P value. So now you have to create the new P value because our previous P value is the same as that of the X. Okay, now the fitness in the current position, this 49.6357 is greater than of the this one. So now the P best is my corresponding to this 49.6357. So what is the value of the X size corresponding to 49.6357? So look at this slide. So this is my first value, 49 point this one. Okay, so the corresponding value is this one, 3.4712, 5. So my P best value for the first component is 3.47 and 5. Clear? Because there are population size 5, so you have to compare 5 times P for each row. Similarly, for the second one, compare this 37.6669 with the previous value. If you find better, okay, then the personal best value is this one. Otherwise, the previous P best value is there. Okay, so similarly, look at that. Look at that. So this is my, after the second comparison, you get this one. After the third comparison, you get this one. After fourth comparison, you get this one. Then this one. Okay. So now you get the P best value, that is called as a PKI. You get G best value, okay, and you get initial value also. Then again compute the equation number 1.5 for the velocity. Okay, then now remember, for the equation 1.5, there is a pki. Pki is your this one. This is your pki. Now here is a term pki minus xi. So what is your xi? Xi is your previous slide. That is a new value. This is now your xi. Forget about the previous value. That is the initial value, because this is a new updated value. Okay, so this is my xi. Okay, this is my gi, that is g best value. This is my g best. Okay, this is my p best value. Okay, and compare that, you will get the third equation. You will get new xi's are this one for the first component. Okay, and similarly, now this is your x. Okay, now find the fitness value again. Okay, among 5 values, find the again global value. If you find better value than the previous, replace that, otherwise not. Then find individual element wise, then compare the fitness value. Okay, if it is again better, update the p best value with a new one, otherwise not. So after that, you will get the fourth equation is this one.
It is all complete. It is complete.
It is complete. Okay, so hence the optimal value is 5,5, because all are value 5,5 approximately. So after that, there is no movement. Okay, so 5,5.
How it is to more iteration, the first value will also be converted into.
After one more iteration, say fifth iteration, the next value is 5,5, 5,5. So up to the 20th iteration, if you are computed 5th, 6th, 7th, 8th, you will get 5,5. So that is all the values are same. So if your values this are same, then your objective function value is again same, because if this is your x1, this is your x1 and x2, you get something value, say alpha. Then corresponding to this value, you again get alpha, because x1 and x2 are same. Then there is no global best p. If I say 5, 5, 5, 5, which one is the maximum? All are maximum. Okay, so then you will get the max, because our problem is maximization. Remember that. That's why 5, is there. Okay. On the other hand, I just replace the same problem with my minimization. अभी हमारा target था maximization करना. Okay. Now just replacing the minimization. Now what will happen? Same objective function हमारा, same C1, C2 की value लिया हमने, same omega, same R1 and then so on. Okay. Now initialization हमारी same थी बिल्कुल हमारी. Okay. Now our target is to find the minimum. So this is my first initial. अगर हमने first maximization किया था तो हमारी ये value आई थी maximization भी. Global best हमारा ये था. Okay. Now our target is to minimum. Okay. Just replacing maximization to minimization. Rest all are same. So this is my minimum value. So corresponding, this is the global. Okay. So this is the third position. Okay. So this red color is my global best. Clear? Then since there is no iteration previously, because that is the maximization problem, that is a separate sum. Okay. So this is a new. So the p best is same as that of this one. Okay. Then compare, then calculate equation 1.5, 1.6. You will get the updated particles form. Okay. That is this corresponding to each elements are there. Okay. Then again, this is my exercise. Find the fitness value corresponding to this. You will get the new values. Okay. You will get this number. Okay. I just say you will get this number. Okay. Find the minimum among them. That is the global best. Okay. Then compare this global best with the previous global best. Okay. If you find better, then replace the previous value with a 6.5480, otherwise not. So now see, look at that, my previous value is 13.29, and now this time our target is to minimize. So definitely we replace that. Okay. And since this is my second number. Okay. So now my global best is my this, which I've shown in the red color. Now new global best is 1, 0.35 and minus 0.0475. Okay, and then again P best is same. Okay, compare this line value with the previous value. If you find the minimum, update, otherwise not. Okay, now again you get the G best value, you get the P best value, find equation 1.5 again, and then you will get after the third equation this number. Okay, so I'm just summarize all this in the one table. This is my fitness value. Okay, the minimum among them is 3 point. Okay, so this is my global best comparing the previous value. Okay, after the fourth iteration, now this is my global best. Now compare this with the previous value. Now there is now previous value is minimum, so the global best remain the same. You can't change your global best. So G best is remains same as that of this one, because 16.78 is less greater than of the 3.52, and our target is to minimize the function. So your global best is same as that of the previous one. Now update the now see what is the P best value. So compare. This is my for the first particle. This is 18 point. This is 39 point. So for the P best first particle, this one. Okay, अगर आप P best बनाओगे, so the first number is this one. Now this is 16 point. This is 16.16. Now minimum number is this. So for the second P best number is minus 1.44. For the third one it's a 25. It's 11. So now this is minimum. So for the P best, this number put up in the P best column. Similarly for the 28, 25, and then so on. Okay. So after the fourth iteration, so after the 20th, because my target 20th tak hi tha, so after the 20th, you will get this one. Again, you will see there is no optimality there, because this objective function is not a uniform. Like say in the previous maximization, it's all are bounded on the endpoints. So, but our restriction is up to the 20th iteration. Okay. So after the 20th, whatever the answer you get, that will be the optimal. That is near to the global. It's not exactly global. So after this, what is that? So what's that? Your minimum is minus, because it's a negative. Okay, so minus 6.33 is my final global best answer, and since global minimum value. Okay, global best because our objective function is minimization, and since this is the 20th iteration, and after that there is no relaxation, because our condition is that we have to move up to the 20th iteration. So the corresponding solution is this one. So my best optimal solution is, my best solution is minus 2.7015 and minus 3.3. Okay. If you find more equations like say 21, 22, so definitely the optimal answer will improve that. Okay, this is how the PSO algorithms work manually. But are you guaranteed that this optimal answer minus 2.7015 and minus 3.3216 is the optimal or not? Okay, you can't say that. This is not the optimal, but this is near to the optimal. Okay, so in order to validate it, we used some, in order to comparison it, so we use a classical method. That is again same, first derivative 0, second derivative greater than or less than 0, and prove that your answer is near to this optimal solution. Then you can say that PSO algorithm works on that. Okay, so what is that? Since my objective function is same, okay, and my target is to minimize that. So what is that? First derivative 0, second derivative is greater than 0. So now look at that. First derivative is with respect to x1, 2x1 minus x2 plus x1, 2x1 minus x2 plus 2, 0, 2x2 minus x1 plus 4, 0. This is partial with respect to x1. This is partial with respect to x2. After solving these two, you will get this one. Okay, this is called as the critical point. Okay, and then you have to check whether there is a maximum or minimum. You can create the Hessian matrix. Okay, or somebody say RT minus S square. If somebody is in the lower classes, partial derivative with respect to x twice, partial derivative with respect to y twice, partial derivative of x with respect to y for the two variables. Okay, so this is there, and this is the positive definite. Positive definite means the first principal minor is 2. it is greater than 0. Second principal minor is create a 2 by 2 matrix, okay, and find the determinant. So what's the determinant of this one? This is 4 minus 1, 3, again greater than 0. So both are greater than 0, so this is a positive. So it's a convex set. It's a convex function. So and the minimum is this one, because this is a stationary point. And look at our optimal solution. It's minus 2.667 and 3.33. And what is our solution? It is near to the exact optimal. As we say that this is not the optimal solution. PSO is not exactly optimal because equation number is very small, 20. Moreover, our population size is also very small, 5. If you just produce a 50 population size and equation number to be 25 and 30, then you will get this number also, minus 2.6667 and 3.333 something.
What are the limitation for this optimization technique?
Limit
Is there any limitation that what kind of problem we cannot solve using PSO?
No.
Is there any limitation?
No, there is, as such, there is no limitation. Any optimization problem we can solve with the help of the PSO.
More accurate, according to your opinion, because we are doing here ABT condition or something, and we are doing PSO, then which one is more appropriate? We can reach.
Okay. KKD condition or classical methods are working only if you are able to calculate the first and the second derivatives. Okay. But if the functions are like say, which are unable to calculate the first and second derivative, you see that in our PSO algorithms, 1.5 and 1.6 or all the mechanism of the PSO or genetic algorithms or evolutionary algorithms, nowhere the partial derivative stands. कहीं पे भी partial derivative का नामो निशान नहीं आया. First derivative, second derivative नहीं आया अभी. Okay. And secondly, KKD conditions, Lagrange multiplier methods, all are working only if your function is convex. Okay, you have to check firstly whether the function is convex or not. If the function is not convex, then you can't say that your local solution is a global solution. But in the PSO or evolutionary algorithm, there is no need of finding the whether your objective function is convex or non-convex. Take the objective functions, apply the algorithms, and solve that.
And we don't bother about the differentiability.
Differentiability. There is no bothering about the differentiability. Okay, like one restriction on the particle swarm optimization and the genetic algorithms or the artificial bee colony is that one theorem in the optimization technique, in the optimization is no free launch theorem. That is one of the famous theorem in the results or theorem in the optimization technique. There is a no free launch theorem. It says that for a particular problem, if you apply PSO algorithms, if you apply the genetic algorithm, if you apply some other algorithms, no guarantee that anybody gives the optimal solution. Exactly optimal solution. Her PSO algorithms is not able to do all types of the problems. Genetic algorithms is not able to solve all types of the algorithm, all type of the optimization problem. But it doesn't mean that for some objective functions, they are unable to solve the problem. It means that they are unable to give the exactly optimal solution, but they give the near to the optimal solution. Like say, a simple example, this is my optimal solution by the PSO. If you apply the genetic algorithms corresponding to this same problem, if you apply the artificial bee colony algorithms or other algorithms, you may get a better solution this one, or you may get a worse solution corresponding to this one. Simple, one more simple example. Same example, you apply the PSO and genetic algorithm. You will get a PSO better result. Okay. Then for the second problem, एक नई problem create करो. Okay. Again apply the PSO and the GA. Then it may that GA perform better than the PSO. That's the free launch theorem says that. It doesn't mean that if PSO perform better for the one.
We have to start some problem, and we should know that which method, which technology we can employ on that problem. So firstly, we should decide whether we have to apply genetic
No.
PSO.
If you are doing some research on that, okay.
Before starting the problem, we have to do some solution, and which technology we have to use, PSO or genetic.
Any one of them. You can use any one of them. But if you want to get exactly optimal solution, then apply both of them on that, and then compare the results. Because otherwise, if you choose the PSO particles, it means
Whether the restriction for that PSO is best for that.
no. That's why I'm saying that there is no free lunch theorem says that no algorithm is best for some problem. Some algorithms are best for the other problem.
And except these two techniques, we should have some more techniques also.
I'm saying artificial B cloney algorithms and cloney, okay, or like say
Discuss here only PSO.
I'm discussing only on the PSO because the mechanism behind all the evolution algorithms are on the this one.
Computational technique, like computation procedure edition is more easier than these.
All are equivalent. The only mechanism behind is that in the PSO we use 1.5 equation, that is the velocity updation is there. While for the other, instead of the 1.5, there is other equations which are related to that particles, that optimization. Only 1.5 equation is updated with the help of the others. Like say if you use genetic algorithm, if you use artificial B cloney algorithms, then instead of the 1.5, replacing 1.5 equation with the artificial B cloney algorithms equation, then the algorithm works that. So this is how the particles form optimization or evolution algorithms works in our day-to-day life and use them manually. Okay. So remember always the G best as well as the local best, personal best and the G best. Okay. So this is simply a step-by-step procedure for the algorithms. If somebody wants anything, doubt or anything procedure how to calculate this, you may ask me, or even drop me a mail regarding any query for the particles form optimization or any other algorithms, okay, or go to my websites, okay, for some future help for other updations are there, you move on that.